that is called Stereochemistry in paper number 402, unit number 4. See, you know that in this paper you can have a, see, this syllabus is totally new and one batch is passed out, that is from during the period of lockdown, so on online mode, and right now you are also studying in the online mode. So this unit is very important, that is called stereochemistry. Now see, what are the topics which we will going to cover in this unit? So one of the important topic is, here you can have a different terms. See, this is the syllabus. You look at the syllabus carefully, then we will start. So see, these are the topics where we will going to learn in this semester. The first one is the identification of different terms. That is, you can have a, what is stereochemistry, what is enantiomer, what is diastereomer, what is conformation, what is we call configuration, then definition of epimers, anomers, chiral carbons. Okay, so these are the various terms: pro-chirality, mesocompound, optical activity, specific rotation, heteroisomerism. So these are the various terms. Then second, after introduction of this term, then you can have a CEZ nomenclature. After that, then we will going to move to the determination of relative, or you can say absolute configurations, and resolution by chiral, gas chromatography, HPLC technique, physical and chemical properties of stereoisomer, pro-chiral environment, stereoselectivity, or sorry, stereochemistry in SN2, stereochemistry in E2, stereochemistry of Diels-Alder reaction, and stereochemistry in addition to carbonyl compound, that is called Krebs rule, and chiral drugs, and stereoselective and stereospecific reactions. So these are the different topics which we are going to cover in this unit. So now on the basis of that, you can have a, first we start with the what is stereochemistry. Okay, what is stereochemistry? Definition of stereochemistry. Is there anybody is knowing what is stereochemistry? What is it? So see the term stereochemistry, that is, first one is what is stereochemistry? How to define it? So stereochemistry, what is how to define it? So it is just a branch of chemistry that deals with the study of three-dimensional structure of molecule. It is a branch of chemistry It is a branch of chemistry that deals with study of three-dimensional structure of molecule. So see, this is we basically called stereochemistry. Okay, it is in short, it is deals with the three-dimensional structure. And if you know that for that you required very important center, that is called, in order to getting optical activity, what you needed? You needed chiral center. What is chiral center? Another is very important things is you required is chiral center. What is chiral center? The definition of chiral center is very important. That is, you can say tetrahedral carbon attached to four different ligands. Tetrahedral carbon, tetrahedral atom. That is a general word. It may be carbon, nitrogen, phosphorus, whatever. Tetrahedral atom attached to four different atom, or you can say group of atom. Tetrahedral carbon attached to four different atom, or you can say four different ligands, is called chiral carbon, chiral center. It's called chiral center. This is just a definition of chiral center. So in stereochemistry, we are studying such type of the molecule. So is there any idea about chiral center? How to write a chiral molecule? Suppose say you are having carbon which is attached with, suppose you may have a carbon which is attached with the you can have a, for example, carbon which is attached with COOH group, four different group. One is CH3 group, other two are, one is hydrogen H which is on our side, and you can have a OH. So is it this carbon is chiral? Yes or no? આ કાર્બનને કાયરલ કહેવાય કે નહીં? Can we call this carbon as a chiral? ચાલો આ ચારેય ગ્રુપ આપણે ડિફરન્ટ લીધા છે. તો જે સેન્ટ્રલ કાર્બન છે એને કાયરલ કહેવાય કે નહીં? Yes or no?
Yes, sir.
Yes, it is a chiral because all four group attached with this center is different. So see, that is you require see molecular asymmetry. This carbon is a chiral. It is a chiral. Star carbon. The center is called chiral center. What is required? See, suppose you are having two group are similar. Like here you can have a two hydrogen and two group are different. Then this carbon is not called chiral. It is not a chiral. It is a chiral. Because you can take a plane which is passing through these two different group. So you can have a plane of symmetry. Okay, if any kind of symmetry is present, then molecule is a chiral. If you take all four group are similar, then you can have a C2 plane. You can take this two group are similar and this two group are similar. Then you can have a two plane of symmetry. You can either take this plane or you can take this plane. So plane of symmetry is there. So in order to getting optical activity, all four groups are required different. Otherwise it is achiral. So now this center is called asymmetric center. Symmetry is absent. Chiral center is also called asymmetric center. Symmetry is absent and such carbon is chiral. So in this way you can see predict whether it is chiral or not. But important thing is molecular asymmetry is required. Molecule છે ને asymmetric હોવો જોઈએ, then it is chiral, otherwise it is not chiral. And for asymmetry you cannot have a square planar arrangement. You can have always, you can say it is arrangement become it is a tetrahedral. That is required. See in the what is applications of this chirality, or you can say optical activity. So number of applications are there. Most of the drugs are optically active or it is chiral. So few drugs are there where plus form is useful to decrease blood pressure. Few drugs are there where minus form is responsible to increase blood pressure. Okay, so once a sign of optical activity is changed, so you may got change in its property. Sugar having C2 form, plus and minus. So plus form is having sweeter taste and minus form having bitter taste. If you go for sugar, so plus form shows sweeter in taste. At the same time, minus form shows bitter in taste. So once optical, say sign of optical activities change, so property gets changed. How to measure optical activity? See, optical activity is based on the chiral center. Compound, when we call compound is optically active. Okay, so optical activity, that is symmetry elements are absent. In a molecule, if symmetry elements are absent, then such compound is optically active. So for that you require is, for in order to getting optical activity, you may require compound with absence of symmetry. Any kind of plane is absent. There is no any plane which is present in the molecule. So you can say it is optically active. So for optical activity, molecular asymmetry is required, or you can say chiral center is responsible to getting optical activity. So how that is possible? So see, optical activity is nothing but Asymmetric compound rotate plane polarized light either in a clockwise. Asymmetric means compound having chiral center. Asymmetric compound rotate plane of polarized light plane of polarized light either in a clockwise direction or in a anti-clockwise direction. So phenomenon to rotate plane polarized light phenomenon to rotate plane polarized light is called optical activity. Is called optical rotation. And compound is called optical, and or you can say optical rotation, or you can say compound which rotate the plane polarized light. So such compound is called optically active, and compound is called optical active compound. So see here term optical activity, or you can say optical rotation. That is phenomenon to rotate plane polarized light either in a clockwise direction, or you can have in a anti-clockwise direction. This is a polychromatic light. What is meaning of polychromatic light? It having C component of wavelength in all the direction. These are the wavelength in all the direction. So this light is, we can say, polychromatic. So this is a polychromatic light. So you can have a once you can say go for optical rotation, using polychromatic light, what happens? This is the polychromatic light. Its component are in all the directions. So it is called polychromatic light. And polychromatic light is not useful to getting optical rotation. So you require filter. You can pass this light into particular filter. What you can do? you can pass this light to nickel prism or monochromator, that is filter. This is a nickel prism. So whatever light is coming out from this filter having wavelength in a single direction. So this light is called monochromatic. They are having component in a single direction. So this is a monochromatic light. When this monochromatic light is passing through substance, here your sample is there. So this sample rotates this light either in a clockwise direction or in an anti-clockwise direction. So you can have a rotation of this light either in a clockwise direction or in an anti-clockwise direction. This may be rotate the light in a clockwise direction, or it may be rotate the light in a anti-clockwise direction. Okay, so this is called optical rotation. The substance which rotates the light in a clockwise direction, it is called dextrorotatory. This is called dextrorotatory. A substance which rotates the light in an anti-clockwise direction is called levorotatory. This is represented by plus, or you can have a small d. This is represented by minus sign, or you can have a L. And this instrument device which is used to measure optical activity is called polarimeter. Instrument used to measure optical rotation is called polarimeter. You can have also experiment in TYBSC. So this is this instrument which we are using to carry out to measure optical rotation. So sometimes substance may be levorotatory or sometimes substance may be dextrorotatory. So optical rotation is determined practically by looking structure, by looking its name. You can't say anything about optical rotation. Okay, so this is the way you can have a optical rotation. But what is requirement of optical rotation or optical activity? So in order to getting optical activity, requirement optical activity. Very important requirement is molecule with sigma SN and I symmetry element are absent. That is required. If so, molecular asymmetry is required. So molecular asymmetry is required to get optical activity. That means sigma plane, alternate axis SN, and I symmetry elements are absent in order to getting optical activity. Okay, if they are present, then it is optically inactive. So see, this is the requirement in order to getting optical activity. Okay, so now you tell me. I'm write down here certain examples where you tell me this molecule is optically active or not. COOH, CH3, H and H. Is there this molecule is optically active? Yes or no? What's about first molecule?
First one.
Yes, first one is optically. First one is optically active or inactive?
Inactive.
Okay, first one is optically inactive because the reason is you can have a plane of symmetry. Good. Plane of symmetry is there in the first case, so it is optically inactive. This plane is there passing through these two atoms, two different group. So sigma plane is there. The molecule is optically inactive. What's about second molecule?
Active.
See, second molecule having two chiral center. This is one because all four group are different. OH, H, CH3 and below group, they are different. This is second chiral center. See, in spite of having two chiral center, this molecule is optically inactive. The reason is it has internal plane of symmetry, and that's why I have written molecular asymmetry is required for getting optical activity. See, here sigma plane is there. So therefore, if see 50% part is plus, 50% part is minus in this case. Okay, but net rotation is 0, so it is optically inactive. Total rotation 0 hoga, so it is optically inactive. 50% part is with a plus and 50% part with minus. But of course, second and sorry, third one is optically active. It is active. There is no plane of symmetry. And fourth one is again having one chiral center. There is no plane of symmetry, so it is also optically active. Is it clear? અહીંયા સુધી કઈ ડાઉટ છે? બાકીના સ્ટુડન્ટ્સે માઇક ઓન કરી યુ કેન ટેલ મી. બરોબર, તો હું તમને પૂછું છું કે સમટાઈમ્સ આઈ એમ આસ્કિંગ યુ વોટ એમ આઈ ઓડિબલ, તો એ જવાબ નથી આપી શકતા, એટલે એનો પણ કેમિસ્ટ્રી તો પછી આવે. બરોબર ને? સો યુ અટેન્ડ ધ લેક્ચર્સ વિથ પ્રેઝન્સ માઇન્ડ. Okay, so this is the way you can predict optical activity. Is it clear up to here? Is there any doubt?
No, sir.
Okay. Etasvi, is there any doubt?
No,
Chanak?
sir.
Okay. Desai, Janak, Janakben,
No,
DVS,
sir.
DVS.
No, sir.
હા બોલો મારે નામ ના લેવો પડવો જોઈએ અમુક તો શું છે માઇક ચાલુ રાખી અને પછી આરામ મોડમાં જતા રહ્યા હશે બરાબર ને so see you just look at the presence of plane of symmetry so see this is a cyclic molecule now look at here this is a cyclic molecule so you can have a see two plane one is above the plane another is below okay two plane is there one is above the plane another is below the plane so if you having see here this is chiral center both the Br atom is above the plane. See, two chiral center is there, one hydrogen, one Br, and here there is a CH group and CH2. So this is the one chiral center, this is the second. My question is it this molecule is optically active? Chiral center are two. Is it this molecule is optically active?
No, sir.
No, why?
Plane pass થાય છે વચ્ચે.
Yes, it has plane of symmetry passing through middle. What's about this one? See here it is a plane of symmetry. Look at here. So this is having plane of symmetry. So it is optically inactive. What's about second? C2 axis હોય તો ચાલે but plane અથવા તો center of inversion I or you cannot have a alternate axis. Here you can have a you can give the rotation so BR above the plane છે અહીંયા. Here it is below the plane so you can have a rotation at 180. C2 axis છે if you want to take but plane is absent. C2 axis હોય તો ચાલે it is this is molecule is called disymmetric. That means it having only CN axis element and it is optically active. Optically active means it is chiral. This molecule is optically inactive means it is achiral. What's about in cyclobutane? See, I write down this two here plane is by dark line. Dark line લખવું એનો meaning એ બંને આગળની બાજુ છે. Dash and wedge projection. ચાલો, is there this molecule is optically active? Yes or no?
No.
No, because it has plane of symmetry. Barabar, molecules is both the group are on our side. What's about this one? It is optically
Active.
that is chiral. There is no plane of symmetry. This is our chiral. What's about this one? જે એટમ માંથી પ્લેન પાસ થતું હોય એની મિરર ઇમેજ ના મળે બરોબર અને જે એટમ માંથી પ્લેન પાસ ન થતું હોય એની જ મિરર ઇમેજ મળે. What's about this two molecule?
Active છે.
પ્લેન છે કે નહીં? પ્લેન એટલે એવો પાર્ટ કે એની બંને બાજુ જે છે ડિફરન્ટ સેમ પાર્ટો જે છે અહીંથી પ્લેન લઈ લ્યો આ રીતે. Plane which passing through both the methyl group જેમાંથી પ્લેન પાસ થતું એની મિરર ઇમેજ ના મળે. સો જો બાકીની બંને બાજુ CH2 છે it has sigma plane. This is also another sigma plane. બંને બાજુ મિથાઇલ front side છે તો it has two sigma plane. So molecule is optically inactive. It is your chiral. What's about second? Second માં પણ આ પ્લેન લઈ શકશો તમે જુઓ. One is on back side, another is on front side. એટલે તમે આ રીતે તમારા મોબાઈલને perpendicular plane વિચારશો એટલે it is passing through both the group. But you cannot have a see this plane. You cannot take this plane. આ plane નહીં લઈ શકો કારણ કે એક મિથાઇલ ગ્રુપ front side છે બીજું મિથાઇલ ગ્રુપ back side છે. So you cannot take this plane. But this plane is there so you can have a, this molecule is plane because of sigma plane. it is optically inactive. જે એટમમાંથી પ્લેન પાસ થતું હોય મિરર ઇમેજ મળે નહીં. What's about this one? Is this molecule is chiral or achiral? પ્લેન પાસ થતું હોય એટલે બાકીની બધે ભાગ સરખામણો જ તો અકાયરલ થઈ જાય, અધરવાઇઝ ઇટ ઇઝ chiral. What's about first one?
Yes, sir. થાય છે વચ્ચે.
તો chiral કહેવાય કે અકાયરલ?
Chiral
It is નહીં, પ્લેન પાસ થતું હોય તો ઓપ્ટિકલી ઇનએક્ટિવ કહેવાય ને.
inactive. હા.
It is inactive. Simply it is inactive. So first one is optically inactive. What's about second one?
Optically active.
Second one is also optically inactive. બંને બીઆર કઈ બાજુ છે? ફ્રન્ટ સાઈડ છે કે બેક સાઈડ?
Front side.
Front.
હા, તો વચ્ચેથી પ્લેન છે જ ને. You can have a see plane of symmetry. You can have a see this plane of symmetry. Look at here. Here you can have a, this is a plane of symmetry. અહીંયા પણ અહીંથી પ્લેન આમ લઈ શકશો એટલે મોલેક્યુલના બે સરખા ભાગ થશે જ. So both having C sigma plate. So it is achiral. This is also achiral. What's about next one?
Active, optically active.
Yes, good. એક પ્લેન એક બીઆર આગળ છે, બીજું બેક સાઈડ છે. So you cannot have a plane of symmetry. So it is optically active. Sigma plane is absent. So molecule is optically active. This is a requirement. See. Now what's about this one? Next.
Optically inactive.
Yes, here you can have a plane of symmetry. Look at here. So it is inactive. What's about next one?
Optically active.
Yes, you cannot see here plane of symmetry. એક બીઆર આગળની બાજુ છે, બીજો પાછળની બાજુ. So plane is absent. So it is optically active. Okay, you cannot have a plane of symmetry. What's about this one? Here one BR and second BR here.
Optically active.
Inactive. This is a plane of symmetry. એક બીઆર ભલે આગળની બાજુ હોય, બીજો પાછળની બાજુ હોય, પણ બીઆર ની અંદરથી પ્લેન પાસ થશે એટલે એની મિરર ઇમેજ નહીં મળે. મિરર ઇમેજ તમારે બાકીના એટમની જ જોવાની. બરોબર? So you can have a, this is optically active. Sorry, optically inactive. Plane of symmetry છે ને?
Yes, sir.
આગળનો અહીંયા આગળનો કેસ આપણે એવો જોઈએ તો એક કેસ સિમિલર કેસ પ્રીવિયસ અહીંયા જોઈએ તો જુઓ લાસ્ટ સ્ટ્રક્ચર છે જ અહીંયા. Same way here it is optically inactive. So see, this is the way you can predict optical activity. Okay, so this is very, very important concept. Now, after checking see optical activity, then very important things is where to represent molecule in a different conformations form. Because in your syllabus, you know very well, you can have a see concept of optical activity that is we have finished. Then you can have a see different projections, line drawing projections, Fisher projection, Howard projection, and then you can have a nomenclature of RS and EZ, D capital DL, small dl, cis trans, 3O erythro. This type of nomenclature are there. Meso compound is there, optical activity. So what is called meso compound? What is called enantiomer? Okay, so that is there in your syllabus. So First, we go for how many different ways which we can represent conformations. Okay, different ways to represent conformation and how to assign its RS nomenclature. That is very important to represent different compounds and how to write down its RS nomenclature. So first word we go for the types of projection. Where you can represent different compounds. So first one is you can have a Fisher structure, Fisher projection. So see tetrahedral carbon, it is a chiral. Fisher has visualized this chiral center in this way. This carbon which is on our side, COOH is on our side, CH3 group is also on our side. So group which are there on vertical line, these are on our side. See these two group are on our side and these two group which are away from or which are on back side. So this is called say Fisher projection. This is a Fisher projection. This carbon is in the plane of your mobile. These two group which are away from viewer, that is on back side of the plane. These two group which are on back side of the plane. These two are actually the group which are there on horizontal line are taken close to viewer in a front side by Fisher, and those group which are there on back side which are taken on vertical line, that is away from viewer, because we are standing in front side. So what happens? These two groups are away from viewer. Carbon is in the plane. These two groups are away from viewer, and these two group which are towards, or you can say on the front side of the viewer. This is the way where Fisher have represent the projection. Carbon is in the plane, COOH and CH3 are on back side. H and OH are on front side. We are looking molecule from front side, so CH and OH are close to viewer, closer to viewer, and vertical group are away from viewer, and carbon is in the plane. So see, this is called Fisher projection. Okay, two group which are out of plane, two group which are on back side, two group are on front side, and carbon is in the plane. So same tetrahedral geometry is there. Fisher have visualized in this way. This is called Fisher projections. So according to Fisher projection, what you can do, you can have a RS nomenclature. where certain rules are there in order to give RS nomenclature. So RS nomenclature, or it is also called absolute configuration. Absolute configuration of chiral center. How to assigning absolute configuration? So for that, certain rules are there. First rule is priority. Rule number 1 is priority rule. First rule is priority, or you can say sequence. Sequence rule, or sometimes you may call it is as a priority rule. That is, according to this rule, assign priority order to 4 different substituents attached to chiral center according to their atomic number. This is the first rule. Assign priority to all 4 group attached to all 4 group, or you can say ligand or substituents attached to chiral center according to their atomic number. This is called sequence rule. Suppose you can have a Cl and Br atom. So which group got priority 1?
We have first CL પછી આવે છે.
Here is the second one, yes. Suppose if you're having H and Cl, then Cl got number 1 and H got number 2. So this is called priority rule. Now sub rule is also there. This is a priority. If 2 atoms having same atomic number, then in the case of isotopes where same atomic number, then you can go for mass number. If two atoms directly attached to chiral carbon having same atomic number, that is called isotopes. That isotope with higher mass number given first priority. Then isotopes with higher mass number given priority first. This is a sequence rule, and journey is continuous till the priority is not decided. Your journey is continue Still priority is not decided. તમારે કન્ટિન્યુ મોમેન્ટ રાખવાની છે જ્યાં સુધી પ્રાયોરિટી નક્કી ન થાય ત્યાં સુધી your journey is continue. Still priority is not decided. For example, here it is CH, CH2, CH2, CH3, and the second group is CH, CH3, CH2, CH, Cl, CH3. આ બે ગ્રુપમાં એક નંબર કોને આપશો? You have to getting priority. So first, see these two groups are attached to chiral center. So here it is a chiral center. So this is just a chiral
સર
center.
કાર્બનની સંખ્યા વધારે નહીં ને?
એને નહીં આપવાની, કન્ટિન્યુ રાખવાનો. અહીંયા આ કાર્બન છે એ chiral center સાથે અટેચ છે, તો અહીંયા પણ કાર્બન છે, બંનેના એટોમિક નંબર સેમ છે. આ કાર્બન સાથે બે કાર્બન અને એક હાઇડ્રોજન છે, તો અહીંયા પણ બે કાર્બન અને એક હાઇડ્રોજન છે. એટલે પ્રથમ એટમ બંનેમાં સેમ છે, તો આગળનો એટમ જોવાનો. આ CH3 ને અટેચ છે, અહીંયા CH3 છે, આગળ અહીંયા CH2 છે, તો અહીંયા પણ CH2 છે, બરોબર. પછી અહીંયા આવે છે કાર્બન સાથે એક કાર્બન અને બે હાઇડ્રોજન. અહીંયા કાર્બન સાથે એક કાર્બન, એક હાઇડ્રોજન અને એક Cl છે. જુઓ, આ કેસમાં બે હાઇડ્રોજન છે, આ કેસમાં એક Cl છે, તો કોની પ્રાયોરિટી વધે? હાઇડ્રોજન કાર્બન કેન્સલ થઈ જાય, અહીંયા એક હાઇડ્રોજન છે એની જગ્યાએ Cl છે, તો Cl નો એટોમિક નંબર વધારે હોય એટલે આની પ્રાયોરિટી ફર્સ્ટ આપવાની, અને સેકન્ડ આને જર્ની કહેવાય, કન્ટિન્યુ કરી કહેવાય, કે જ્યાં સુધી પ્રાયોરિટી નક્કી ન થાય ત્યાં સુધી આગળના એટમ પર મૂવ કરતા જાઉં. સો યોર જર્ની ઇઝ કન્ટિન્યુ. સ્ટીલ ધી પ્રાયોરિટી ઇઝ નોટ ડિસાઇડેડ. Chalo, next lecture ma now we see the chirality rules. What is chirality rules and how nomenclature is decided using chirality rules. So that we will see in the next lecture. So up to here, if you having any doubts, then you can ask me. Otherwise, we stop here. Thank you very much.
સર આ લેક્ચર તમે રેકોર્ડ કરેલો છે સર?